Okay, so today's lecture is going to be about cores and cavities, which is about generating molds for an object. Okay, so think about it. In the industry, in like injection molding and casting and forging, you need to generate a core and a cavity to build the product, to build the object. So we're going to learn how to generate these two models. Because who wants to really sit there and use the extrude tool for this and use the revolve tool and figure out the negative of that? Who wants to do that? So we're gonna learn how to use a set of molding tools to generate that in one shot. I'll show you another way to do this also using the combine subtract add tool as well. So I'll show you two different ways that this can be done. And this is gonna help you on the homework. Okay, so you'll have to do the same thing. Which is to generate molds for this cover. And again, all of that is on the app. So you just go to homework 10, you pick the instruction sheet, you do the models, you submit, and the same deal as before. Okay, so to begin, we're going to take this one step at a time. First, let's understand some terminology here. This is the core, this is the cavity. So this is a cross-section of your mold. Here's your mold. That very thin feature is your mold. So couple terms. In this tutorial, we're going to learn how to build a parting surface. You see this? This is a surface that we build. It's a geometry that we build using the surfacing tools that the software needs in order to split, to generate these models. We need to build this surface so that the software can build the core and cavity. Okay? So that's what a parting line is. That's the chamfer, the surface, and all that. You also have an alignment chamfer here. This is so that the two molds mate perfectly when they come together. You don't really want to just have a dowel pin here or there. That's not a really strong alignment. A 20-degree alignment that goes all the way around is much stronger. Pretend like this block is like chewing gum. If you have like two pins on the sides and this is chewing gum, you're not going to get a lot of alignment on those sides. So an alignment chamfer is really good on a core and cavity. And then finally, we have shut-off surfaces. This is where the cavity and the core, they touch each other. Because if you notice on this object, you have some openings, like on the screen and on the push buttons. You don't want material there, so you need to specify in the software where the shut-off surface is. Okay, so this is what we got to mold. So here are the shut-off surfaces, here are the push buttons, and we're gonna go ahead and generate the molds for this. So first thing we gotta do is turn on the mold tools. It's called mold tools, okay? And then these are the tools that we're gonna use today. There they are. Okay, the mold tools. But before we mold, we should analyze our model for different reasons. For one, we want to analyze the draft. Okay, so the draft is kind of like looking to see how much of an angle is on the sides. The more draft, the better, because it's easier to eject it from the molds. And sometimes it's good to run a test to see how much draft our part has. So I'm just going to pick a reference plane here, and we're going to take a look at how much draft we have. So you see, here it says it requires draft. Here it says it's got negative draft, and then here it says that it's got positive draft. So the green is good. So as you can see, when I put a lower number, it's going to be more strict. But if I put a higher number, it's gonna say it needs more draft. So it really depends on the tolerance that you set. And ideally, you don't want to have an orthogonal 90-degree surface. That's not good. So maybe maybe a degree or 0.5 of draft could be okay, but try not to keep it orthogonal if you don't have to, just so it makes it easier. We're going to stick with this, but ideally you'd optimize this. You'd add a little bit more draft here and there to make it really smooth when it ejects. Okay, so we're just going to click OK. The second test you might want to do is called an undercut analysis. And this kind of checks to see if there's any undercut pieces. So let me give you an example. You see this? See the red? That's what it's telling me. It's saying there's an occluded undercut. So this is not good because when you eject a mold, it's not going to eject if there's an undercut, right? Because it's going to be in the way. Unless you have some sort of actuator or something like that, but it's going to cause all kinds of alignment issues. You know, this is precision. Mold making is a very precise specialty in machining. Okay, so you don't want to lose that. So this just tells you that there's an undercut problem. So if I delete this model and I rerun this undercut, see now the error is gone. There's no undercuts. It's 0. So anyways, that's how you use the draft analysis and the undercut analysis. You use it to optimize your mold. Okay, and then there's other tools out there like SolidWorks plastics to see how well you distributed your plastic, and then there's also FEA that you can do to see how strong these thin features are by adding more ribs and things like that. So there's a whole lot of other things you can do, but those are some of the more common things that you check before you run the molds. Okay, so now we're ready to add the parting surface, and that starts with the parting line. Okay, so to begin, you have to prime it with the top surface, the top plane, then hit draft analysis, and now you're ready to go and pick your parting line. So this is supposed to go on this outer edge. You see that? Okay. And we're going to just kind of go one line at a time. Okay, so we're going to select each line and go all the way around. So there's no tangent propagation button for this. This is all done by hand. Okay, it has to go all the way around. So here I am going all the way around. Okay. And there we have it. It's got a closed full circle. Click OK. And here's our parting line. Okay. So now the next thing we want to do is generate the shut-off surfaces. So there's a button for that. It's going to kind of generate the shut-off surfaces. So we just really have to click it, and it figures it out. And you get a green box when it's done. So it says that this is an opening. This is an opening. So the core and cavity is going to touch on these locations. So we're going to click OK, and it's going to create some sort of mesh, some sort of like surface to fill those in, as you can see here. All right. Then let's see what else. Okay, well, we are ready to build the surface now that we have the parting line. So it's going to be parting surface. There it is. And it knows where the parting line is. And let's see if we can follow the instructions here. Perpendicular to pole, parting line, we got 1.3. It's important to follow these exactly, because if you don't, you get all kinds of problems. 1.375. It's going to be a hard corner. And knit all surfaces. Okay, let's see what we get here. Okay, so there it is. Alright. Now we got to create our alignment chamfer by using the ruled surface tool, tapered to vector. So it's going to be ruled surface, tapered to vector on top plane. And the edge is going to be this edge. We're going to have to go all the way around. Again, we're creating a surfacing, parting entity that will allow us to split the core and cavity. This is what we're doing. See, we gotta change the direction, and let's see what the thickness is. 1 inch. And both of these are gonna be turned on. Okay, just like that. Ooh, knit failure. Let's see if we can. 20 degrees. Let's see what happens if we do 20 degrees. See, little details like that, and it'll give you problems. You got to be very careful. Okay, the next step is to set the foundation for this. Okay, we need to know where to split it. And to do that, I'm going to create a surface that touches the bottom of this chamfer, and I'm going to knit the two. So to do that, I'm going to create a plane. on that surface that's parallel to this. Ooh. That's not what I wanted. Parallel. There you go. Okay, parallel to that. And then I'm going to draw a circle on this. A big circle. Just so it can embody the mold. It needs to be larger than the mold block. Okay, and now we're going to use a surfacing tool called planer. Okay, it just creates a plane out of that surface. And we're going to have to knit the inside. See what I'm saying? Just like that. Trim and knit the parting surface. Just like you see this. So let's see. We're gonna knit. We're gonna trim this off. Let's see. Trim surface. Okay, we're gonna pick these two, and then we're gonna remove the inside. Okay, we're gonna remove the inside of the two. So this looks good. It's hollow. And now we're gonna knit this because remember, you see this blue edge? It's gotta be black. It's gotta be black for this to work. So it's going to be 1, 2, 3. Let's see what we get. See, there you go. Now we got a black edge. So this is all one piece now. Okay, so now we're ready to build the mold. So if you did everything correctly, this should work in one shot. Okay, and we're going to do that with the tooling split button. So this is the final button. So we got to pick the this parting surface, and then it says, well, I need to know the size of this block. So I'm just going to create a cube here, and it's going to be 15 by 17. This is what you attach to the press, to the injection machine. Oh, this is just a plane, I think. Yeah, it's just a plane. Okay, so this is good. And then we need to know the thickness. So it's going to be 4 inches. Okay, so 4 inches. Okay, so we set the distance, we set the box. We also have to select the parting surface, which is this. Okay, don't forget to select that on the third box. And then let's see what we get when we click OK. Okay, you see that? The molds are generated. Alright, let me explain what I mean. If you fire up the move tool, move bodies, you can select what you want to move, then hit this button here, translate rotate, and you can move it like 8 inches or something like that. Let's try it again for the lower one. Move this one -8. Okay, so look at what we got. Here's the core. And here's the cavity. Alright. And we can hide this surface. We don't really need it anymore. Don't delete it, but just hide it. Same with the shut-off surface. Just hide it. Okay, and then this is the final result. So this is what you can submit for the homework. This homework is the same idea, but you submit this. It's not an assembly. It's a part with 2 molds in one shot. If you want to save this as its own part, you have to select it here and do insert into new part. And then you have to save it, click OK, and it's going to insert it into its own file. So you can open it and do you know, a detail. You can import this as a detailed drawing or something like that and do all kinds of manipulations for this. Okay, so that's how you can open that up as an individual file. So another way I like to generate molds is not only with the mold tool, but also through the combine tool. I actually kind of prefer this way because it's a little bit more simple. So let's pretend I got 2 pieces on this part, and let's say I want to create a cavity of this. So you just fire up the combine tool and you pick subtract. You select the main body that you want to keep, then you pick the body to subtract, and you can even show a preview and click OK, and then you get a negative of that. and there's the combine step. So I personally like this technique a lot better than using the mold tools that you see here. And finally, a couple last pointers about injection molding is that one of the issues that arises that when a part solidifies and cools down, it shrinks by 7%. So what a lot of engineers do is they scale their molds. They scale it up by 7% so that when it cools down, it comes down to the correct size. Also, another thing you gotta realize is where you inject the fluid, where you inject the flow. You don't want to get a short shot on the ends of this cavity, so you gotta make sure that the fluid is well distributed throughout your model. Okay? Because again, you really want to mold everything in one place, in one shot. This way, everything is uniform. So you really got to think about where are you injecting? Is this a critical area of your model? Is it okay if you get a little residual feature that comes out of this when this is assembled? So that concludes the lecture on molds and cavities in SolidWorks.